The purpose of this video is to introduce you to the theory behind collective action problem. I'm going to discuss free riders, coordination games, and how sharing information can help solve collective action problems. A collective action problem is a problem where you have a bunch of people acting independently who would really benefit from working together towards a common goal. The problem is that everyone's individual incentives encourage them to act in the wrong way. The classic example of this is a shared kitchen. You and your roommates would all be better off with a clean kitchen, but no one wants to do the dishes. So you leave yours in the sink, hoping someone else will wash them. But because everybody thinks the same way, the dishes keep piling up and the kitchen gets dirty. That's a simple example, but the logic is the same for bigger societal problems like air pollution or traffic. Everyone would benefit if they took public transportation. People would get places faster and have cleaner air, but nobody wants to take the bus. This is called the free rider problem, when you can benefit from a public good, like a clean kitchen or clean air, but don't have to contribute to it, so you have incentives to just let things slide. A related problem is called the tragedy of the commons, where a community shares a common but depletable resource and keeps using it until they can no longer take advantage of it. Overfishing is the most commonly used example here. There are lots of different types of games used to describe lots of different types of scenarios on collective action, and they all have really cute names. But we're just going to talk about one type here, a coordination game. Coordination games happen when, like in all scenarios we're talking about with collective action, individuals are what is called rational actors, who behave strategically. What this means is that people observe what everyone else is doing and make a cost-benefit analysis on what they should do, based both on what they want and what they think other people are going to do. Coordination games are unique in that they also make an assumption that everyone wants to be with the cool kids, that people are better off in the largest group rather than out on their own. This is why Person et al. Describe corruption as a coordination game. Essentially, why shouldn't any one person take a bribe if they see everyone else doing it? Political protests are also a coordination game. It doesn't make a lot of sense for one or two people to protest because they could get arrested. It only makes sense to protest if everyone does. Many ways have been proposed to resolve the collective action problem. You can provide people incentives to participate, for example, applying social pressure to wear masks, but they can also be resolved through what is called an information cascade. The idea here is that some people are willing to protest and act no matter what. In a protest, they feel very strongly, and they're willing to risk arrest out on the streets. Other people might agree with those protesters, but they're a little more afraid of the consequences of going out on the streets. They're going to watch what happens to that initial protest, and if the first movers aren't arrested, more people will go out and join. Other people then see the second, bigger protest and join the next one. Eventually, the protests get so big that it ends up making more sense to join them than to stay home. This is called a tipping point. That happens when everyone now wants to be on the winning side again, but the winning side is on the side of the protesters, and even the security services are joining in. And that's when protests topple governments. Information cascades require the free exchange of information between people, and so they can be stopped by government limits on the internet or severe repression. But they can help explain corruption, political protest, and even why we see rapid changes in public opinion on social issues in the United States.